Go! Yeah! Last second. I think it's due at 4:30. It should be due at 4:30. If it's not, let me know so I can fix it. What's up?
I have a problem. Not in this class.
Oh, okay. Another class.
Yeah, it's like a general C++ question.
Oh, okay.
So I've got this vector of driver classes, like drivers and like the person who can drive, and then this class inherits from a general person class, which is defined over here. Yeah. So I'm trying to call get location, but the error is that get location is inaccessible.
Yeah. So,
Even though it's defined and it's in the public section of person.image. And so I'm
what are these? Are these pointers? No.
No, just actual instances.
Yeah, that's weird.
So I'm not entirely sure what's going on. My C++ knowledge is failing me.
Yeah, that is strange. Do you have multiple declarations of this somewhere? Person. So what is driver? Driver. Panel. Declaration. Driver derives from person. Person. Virtual. Pair. Get location. I think this is something we can look at after class. But yeah, I'm confused.
Me too.
I would run this to make sure your IDE isn't trolling you, because if it builds, I've actually seen it where it builds fine, but the IDE doesn't like it for whatever reason. It could be an IDE.
I'll try it out. Thank you.
Yeah, no problem. What the? Boink. I need to extend this level and add more characters. Okay. All right. Yeah, definitely. That's going to be required. Okay, everyone. Thank you so much for joining us. I've been teaching for like 4 or 5 hours straight, and so I'm actually going to sit today. If you cannot see me, then you are very welcome to kind of scooch up, story time style, back to middle school. Do you remember doing that in like elementary school? Yeah. It's like, okay, gather around. Okay, so I was in Southfield about a month ago, giving presentations to a bunch of elementary schoolers, and they were doing that. It was very nostalgic. It was adorable. Anyway, make sure we're streaming. Good. Okay, welcome to another week of EECS 498 Game Engine Architecture. It's good to see you. You all look a little bit tired. I can't imagine why. How did your submission go? How many of you are feeling pretty good after homework 3? Okay, that was the warm-up, okay? All right, don't get too cocky yet. All right, people are getting very, very cocky in the memes channel of the Discord server. So please save that for a little while because homework 4 has launched, okay? One of the things that makes this course pretty difficult is that there's just homework after homework after homework. There are breaks, and they are coming, okay? If you look on the schedule, we got spring break. You're going to do nothing over spring break, and that'll be a good chance to relax. But it really behooves you to try and knock these assignments out as early as you can, okay? Because it will start to stack up on you, and it's not going to be very pleasant, all right? But I hope that homework 3 was kind of a good, kind of, semi-relaxing reintroduction to C++, if it's been a while, and also an introduction to the grader, the autograder, and the compilation and submission process, okay, which have a lot of things that can trip you up, a lot of tiny things, as I think some of you have found, especially if you're dealing with Xcode, okay? How many of you had a time with Xcode? All right. All right. Well, I'll tell you, this week, not too bad because you're doing a lot of the same. But the week after, you're going to have your first binaries and dynamic libraries to link against. And it's going to be another IDE experience, okay? We're going to have some nice tutorials, some video tutorials to show you how to hook things up in that first assignment. Last year, they didn't have that, okay? It was chaos, but they made it through, and you will too. So just keep the faith. Okay, so I want to show you really briefly today. I want to show you a game engine. This is a famous game engine. This is an ID Tech 1. Now, I'll be honest with you, this is not an engine I know a ton about, and it's not an engine I've ever gotten to build myself, which is a real shame because this, the famous engine behind Doom, is an open source engine. You can go get it. You can try and compile it. I've tried to compile it, I think about 3 or 4 times in my life and never succeeded, never come particularly close to succeeding. I feel like I'm okay at this stuff. So I wish you good luck. One interesting thing to note is that it's just the engine. You will need Doom assets and packs, content basically, in order to actually run the game. These are the kind of things that you will get on your hard disk if you purchase a version of Doom, for instance, on Steam. You will be able to point the engine at it, and it should launch if you can get it to build. Okay, this is a 1993 era engine. Okay, this is I think before the PlayStation came out. So this is kind of toward the end of the 16-bit era. People are very used to 2D games, and suddenly this lightning-fast action, violent shooter, Doom, comes out, and it is an entirely new, fresh experience, okay? It is a very controversial experience, of course, but it spawned the most popular genre of video games today, the first-person shooter, and it is still a series that is going strong. It was made by ID Software, which is now a subsidiary of which company? Our favorite AAA company, Bethesda, okay? So there's a new Doom game coming out soon, I think. Doom the Dark Ages, kind of a medieval theme. We'll have to see. There's an ebook, a free ebook on the, okay. There used to be a free ebook. I'm going to have to fix this link later on the topic of the engine and kind of how it came to be and its history. And in particular, I took this screenshot from the book from John Carmack, that I thought was pretty cool, okay? He said there are often trade-offs that can be made in the engine that gets you a significant advantage in terms of performance in exchange for limitations in your game design. But if your game design is really good, you can often cover up these limitations to prevent the user from thinking about them or worrying about them. And as a result, you've got an engine that can run lightning fast and a great experience. Remember, this was the era where machines didn't really have a dedicated GPU. Okay, these machines were just barely capable of running a command prompt, let alone a fast-paced kind of pseudo 2.5D first-person shooter game. Okay, there's a video recreation here that's kind of interesting. You can follow a tutorial series to create a kind of Doom-style first-person shooter game from scratch, and you'll end up with something, let's see, like this. Well, actually, no, that's Wolfenstein. You can watch as they basically fake a 3D rendering of a scene in 2D. If you can believe it, this game and the way it works, look down here and you can see it and get a feel for it, is actually a 2-dimensional game, and the way that we render things is basically just a hack in order to make it look 3D, when in reality it is 2D, okay? If you go and look at how maps are made in Doom, most of the maps are actually these kind of top-down 2D images, and you can define walls and stuff, but you can't really go in and define the 3D things within super easily. You can kind of do it. It's funky and kind of messy, but that's how the engine was able to run on just really, 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 really basic and slow hardware, okay? So anyway, you can go look through this more if you want to. I don't want to spend too much time on it. Computer hardware of the time was like this. It was very, very expensive, but also very underpowered, not very fast, and it certainly wasn't designed for action games. It was designed for things like spreadsheets, okay, and basic business applications. Far worse than consoles in many senses, and it used integer math exclusively. It couldn't handle floating point, so you had to use only integer and integer math for all of this. The last thing I'll show is this is called DoomEd. This is the editor. It was, I think, built for the Next machines. Does anyone know what the Next computers were? So you've heard of Windows computers, Macintosh computers, okay, IBM computers. Have you heard of Next computers? Well, they were their own bespoke computers that...
Steve Jobs.
Bingo. This was what Steve Jobs got up to, I believe, after getting kicked out of Apple. Next did some really good things. It had a really impressive API and development environment. They were very beefy machines. And as far as I know, the hardware was developed with the software in mind. So it was bespoke hardware and then a bespoke operating system and APIs on top of it. Very powerful. Macintosh, Apple basically purchased Next when they rehired Steve Jobs, and that kind of became the basis, as far as I understand it, for Macintosh OS X. If you go into Xcode and you program in a language called Objective-C, have you ever heard of that? Right? Used to be the main language for iOS development. That's what Next Step was, right? That's where it was born. And if you go in and develop iOS stuff, you'll see a lot of functions and data types that start with NS for Next Step, okay? So that's where it comes from. Anyway, right, Doom. So you're editing maps. You've got this very 2D interface because it really was kind of a 2D game under the hood, just rendered in a very special way. But this was the tooling that they had, okay? Look at how cramped all this is. They did not have a high-resolution multi-monitor display, okay? Like, this is what they had, and they made do with what they had, and they made some amazing stuff, really transformative stuff, okay? All right, so you can look into this more. Again, I don't know a ton about it, but hopefully it'll be of interest to you. Okay, some quick announcements. IGDA Ann Arbor is this Thursday, okay? This is a monthly meetup. This is a monthly meetup, and you can go there and you can get free dinner. You can get extra credit in this course if you snap a selfie with a speaker. To prove you're there, you're immersing yourself in the local game dev community. We give you a tiny bit of extra credit. You cannot take a selfie with me, okay? You have to get it from one of the other speakers there. I just don't like to be photographed that often. I'm going to be giving a talk this Thursday on the topic of hacking and modding. Okay, Secret Life of Games. We're going to live hack 2 actual games in front of you. We're going to make some very small mods to them. It's going to be a Looney Tunes game for the Game Boy Color, and then we're also going to hack Street Fighter 4, okay, for Steam. So look forward to that. Usually we have a big industry guest speaker, and it's really awesome. This month you have me, so good luck, right? Anyway, should be a good time. Should have a decent crowd there, and you can always register yourself a 10-minute show and tell slot right on there on that event page if you want to show something off for 10 minutes, okay? Really cool news today is that EECS 298, the fabulous course that you should ask me a lot more about, that involves creating your own 3D characters, assets, and all that good stuff. Can I make that jump? I can make it to this, can I? There we go. Basically learning how to author 3D models, characters, materials, animations, and then bring them into an engine. Basically, how do I make all my projects actually look good? Just got FlexTech for this, okay? Hey, there's someone else on the website. A reminder, this is multiplayer. All of your games will be multiplayer by default as well, so you can share and have fun with friends and family. It's FlexTech, which is good news. That allows people to go and get toward graduation. Every single department has their own special types of credit. So stamps has elective credit. Well, this will also count for elective credit, I've learned. But the LSNA, are any of you in LSNA? So LS&A has something called creative expression credit requirements. Okay, and I'm hopeful that we can get this course to count for that as well. Since it is a very creative course, it is kind of midway between art and tech. The problem for all of you is that in LS&A, if you are a computer science major, then computer science courses cannot count for creative expression. So I'm sorry, it won't work for you, but it will be flex tech. That'll still be valuable. Okay. Anyway, if you know of any special departments that have special types of credit you would like this course to count for, please let me know as soon as possible because I need to start those discussions now in order for students to get that. Now, I kind of just love watching people try and climb this thing. That jump right there, do you see that jump where you have to go kind of 180 around the tree? No one can make that jump except for these people, I guess. So very fun. I need to make this harder. As you can see here, we actually have a character select that I made, but it's nothing but peaches. So we have Rayman on the way, and we also have a custom character from the ground up that Evan is working on that we're going to put in as well. And we're going to have just hopefully tons of characters. Wolvie from Wolverine Soft will be in here, hopefully.
Is it possible to create a system where you can upload your own?
I really want to, because I would love for every character that the students make to be available like in this web game, right? But I don't know if that's going to be technologically feasible. We'll have to see. Yeah, we'll have to see. Anyway, yeah, good luck to all of you trying to get to, okay, should I do it real quick? I'm going to show you how it's done. Real quick, okay? Super easy, no big deal at all. You skip that one platform, you just jump right over there. You make this jump right here. You jump kind of around, yeah, never mind. But you can kind of jump around the corner and it's no big deal. And you'll be just fine. The hitbox on the spikes is a block, basically. It's a cube, so it's not pixel perfect. So you might be sad if it doesn't work out. Oh, I just climbed up the wall. I don't think I'm supposed to be able to do that, and I made it. All right, cool. There you go, everyone. Good luck. Okay, so let me know and give me feedback on that course if you have any. All right? Okay, the Get a Job Guide is a big deal. A lot of you are looking for opportunities. I know that they're kind of a bit hard to come across right now. The market is in the pits a little bit. This Get a Job Guide was prepared with myself and some members of Stardoc's recruiting team. And they have a lot of tips that we've accumulated over time. Okay, so please make use of this guide if you can. They're preparation tips. So like how to fill out your portfolio, how to fill out your resume, right? What should you mention? Okay, what skills should you list? We have a bunch of companies here that already have a bunch of Wolverines at them. And so I encourage you to look at these companies. There's some tips on how to apply to them. And in general, if you apply to these companies, you can also notify me, and then I'll notify the companies to take a closer look at your resume, okay? Academic opportunities are a big deal. A lot of you are looking to go to grad school, okay? If the job market's really tough, grad school, not a bad idea. Research laboratories are always looking for people with your skills, okay? There are a lot of them out there. You can apply to them, and you can get letters of recommendation that way. You can sometimes get paid for doing that. And then there's a bunch of websites for just general applications, okay? A lot of my successful students who have found game dev jobs, they got into the habit of making like one application every day, okay? It doesn't take a ton of time, especially if you come up with a template so that you can quickly kind of construct a reasonably authentic, cover letter and stuff like that. But that's what I recommend. Take a look at that Get a Job Guide. It's there for you, okay? A quick tip I noticed for all the office hours and the struggles students had on P3, on homework 3, try and avoid white space and special characters in your file paths, okay? Every operating system treats these slightly differently, and you have to get funky with your formatting and your commands and your paths in your IDEs if you have white space. Avoid white space, okay? Don't create the third-party folder with the space, all right in the middle there. It'll probably cause you pain in the future, all right? Be careful about premature optimization. We got a lot of people in the memes channel trying to one-up each other, how badly they can beat the autograder, okay? Your code base is going to start getting more complicated in a hurry, starting this week. And you really want to focus and optimize for code clarity and expansion. Okay, so keep your code base dry. Okay, what does that mean? We'll talk about it a bit today. But you don't want to have duplication in your code base. You want to make good use of functions. You want to make good choices with variable names and function names. You want to split things up. Worry about performance when the autograder tells you that, hey, we need this to be a bit faster, okay? That's when to worry about performance. And usually you want to care mostly about kind of complexity-based performance, okay? So, do you have an O of one-time algorithm for checking what is at a certain tile? Okay, that's going to be probably a lot better than, I did a bunch of obscure optimizations in some other place, in the dark corners of C++. Okay, so keep that in mind. All right, so okay, really quickly, some questions on homework 3. How did it go? Really quick. Were there any parts that were nasty? I know the spec sometimes doesn't shout everything at you, right? But what was nasty? Tell me what was nasty, because I'm still updating the stuff. Yeah, Jose?
Getting Xcode to work was very fun when I had to. So I understand the spec says you don't want to manually boot in every file.
Yeah.
When it comes to issues. The concern was then whether or not, is it just my main file that runs the engine I have to worry about? Is it like all the other supplemental source files? Do I have to go through third party and manually add in all those files? Which I almost did, and then I stopped for a second.
Yeah, you definitely shouldn't have to do too much in Xcode to get it working, but yeah.
I will say, at least leave a note. What I found working for me was compiler source and build phase. That adding the files that I have to load in there.
Sure. Okay, I gotcha. Yep, that makes sense. Yep.
Whether you can modify map helper?
Map helper?
Yeah.
You can modify it, yeah.
Yeah.
I think you're fine, but if things start to go wrong.
Yeah, it's fine, but it took me a while to figure out what the response is supposed to be.
Yeah, got you. Yeah.
One small point on the spec that I was a little confused about was the ordering of the printed dialogue.
Yeah.
Because by having the bullet points be numbered, I was like, wait, is the numbering saying, also do it in this order, or?
Okay, got you. Okay.
So yeah, that was the only vagueness I had.
Okay, gotcha. Yep.
Similar to that, it wasn't printing the dialogue in order, but it was moving the actors versus moving the player.
Yeah.
What to do first, I ended up doing it the wrong way.
Yeah.
Moving the player first, and then I had some autograder error that I had no idea because it didn't. The output didn't help at all. I was
On these assignments, you don't get a ton of feedback. You'll get much more on homework 5 and 6. That's a big one. Should you consider player special, and in what ways? Well, in one sense, the player is quite special because you issue commands for it and it follows your commands. But in another sense, it is just another actor in the actor list. And if it comes last, you process it last. If it comes first, you should do it first. So it's interesting to think what makes the player actor different from all the other actors besides input. Okay, yes, Evan?
I was just going to say, having a little more guidance on how the file structure should be set up, so I can stop second guessing myself constantly.
Yeah.
Would be great. Because it has first party and third party shown in one of the materials with the space.
Oh, yeah. I know.
Do this thing.
I know. Yeah, some of the guides are getting refactors and getting changes because they've got some stuff in it that probably shouldn't be there. Yes, but in a very real sense, it's kind of capstone-like in that we want you to experiment with your own kind of approach to your code base. But in discussion in particular, we'll give you tips for how, for instance, Nikhil did it. I think sometimes he even shows how I did it. Anyway, okay. All right, a quick thing about office hours. So in graduate school, I discovered a hack, a cheat code that allowed me to defeat all of my assignments and projects easily, right? Usually within the first few days of a deadline. And here's how it went. As soon as a new assignment or project releases, no one will go to the office hours for 3 or 4 days. For half the period, no one will be there. And then everyone will be there in the last couple of days of office hours before the assignment is due. So here's what I would do. In a course like, 587 Advanced Algorithms, I think? No, not 587. In the advanced algorithms course, what I would do is the homework would come out and I would take 30 minutes and I would just rush. I would just create the worst solutions possible to every problem. I would attempt every problem, just get myself thinking about it really quickly. Then the next day I would bring my solutions to office hours and I would be completely alone, right? Completely alone. I would ask the professor or the GSI, hey, here's the problem. Here's my solution. Like, am I thinking in the right direction? And usually they would tell me no or yes, right? They would tell me, yes, this is roughly what, you're thinking properly. Or they would tell me, no, you should be thinking about this thing from lecture, right? And we go, oh, okay, that's a much better direction, right? And then I would take about 15 minutes and I would revise my solutions and I'd ask them again. Eventually, they would basically just kind of hand over the answer or they would tell me the solution. Okay, the point here, though, is that you want to go to office hours early. You want to make use of them, especially early, because that's when they're super available. And your professor, your GSIs, your IAs are not going to be running around from person to person. We can give you really good hints, very personalized hints, and get you on the right path early. Way more efficient way to do this stuff, okay? So anyway, might be useful to you in this course, might be useful in other courses as well, okay? Blah, 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 blah. Don't put your entire project into one file, but if you do, know that this game, Thumper, basically did that. They came out and they did okay, all right? It did take them 7 years, though, to get this game finished, and so that might tell you something, all right? So in any case, you will also, if you put all your code into one file, you'll be in the wonderful company of Yandere Simulator and Yandere Dev, okay? So anyway, my one bit of fun trivia here is that the original person who dumped Yandere Dev source code was one of my friends from like 7 years ago. So anyway, yeah. Okay, I've got a much bigger picture. Okay, you want to see something crazy? Okay, let's check out 494's lecture today. In fact, wait, most of you have taken 494, right? So you've already seen what I'm going to show you. 5,000 line components, okay? Okay, look at all this. And now look at how my scroll bar moves when I scroll down. Uh-oh. Uh-oh. Okay, variables upon variables upon variables. All right? Yeah, make sure your game engine code base. And now the logic here is just nested if-else loops and statements. It's just a complete disaster.
Just one component?
Yeah, this is all still one component. Now we're entering the update loop, so hold on to your horses.
I meant more like, is there only one component on the object?
I think so. This is basically the God component pattern.
So,
where they, they're using a completely centralized approach. Yeah.
Object-oriented doesn't exist here. We have
Okay. Anyway, so let's get back to it. Because, hey, everyone, we do have stuff to do today, and if I don't get through it, homework 4 gets way harder. So let's go ahead and do this. Homework 4, okay? You can look through that component later. I'll show you during office hours, okay? I'll send you the link. Homework 4, all right? Homework 4 is where things really start to get fun, okay? In this first assignment, homework 3, you created a game. You are a game dev. You created a hard-coded homework 3 text adventure, okay? And you can hand that to a friend, and they can play it. They might even enjoy it. However, this is not something that the end user can edit, okay? If the end user doesn't like something or wants to change something, they can't do it. So last week, right, you had all of these actors. You had these actors, they had properties, okay? You had a map that was hard-coded. Remember, this was all hard-coded as in it might look textual to us, but in the binary that our end users receive, it's just ones and zeros, okay? They can't change it. Even if we give them the source code, they might not know how to compile it, okay? They might not have all the dependencies. And so this is just not a good approach if we want people to be able to mod things. What we're going to do this week is we're going to move all this hard-coded data, we're going to move it into the user's file system. We're going to move it out onto disk. We're going to move it into a human-readable format where all of these properties can be easily customized or tweaked or added to as much as we want, okay? Our end users will see human-readable format which they can tweak and edit, and without recompiling the code, they can have a new game if they want to, okay? So why bother? What's the point? Well, we want to provide freedom to our end users. In fact, building a game that can then be changed or modded often makes the game more valuable. Think of how many people are still playing and purchasing new versions of Skyrim. Okay? Bethesda games are not necessarily known for their polish, but what they are known for is their long lifespan and all of the wonderful mods they tend to receive. Okay? Watch this. Resident Evil 2 Remake, right, gets a new character, a new monster character. It is Thomas the Tank Engine. Okay? And you're going to see much more of Thomas the Tank Engine if you go to my talk on Thursday at IGDA Ann Arbor. Okay? This is also a very necessary path on the a necessary step on the path to full expressiveness. Okay? If you say, well, this week we can modify the actors and their location, maybe next week we can change the genre entirely. Okay? We can eventually get to something so expressive that we can leap into a new genre. We can have aesthetics. We can have sounds. Okay? We can have anything we want, any genre we want, as long as it's 2D. Okay? 3D graphics is a different course. All right? Anyway, customizable. People will be able to tweak the positions of the actors, but also the visuals of the actors. What character, what letter will be represented. Okay? There will be physics for the actors. Will the actors be blocking, or will you be able to walk through them? How will they move? Okay, the actors will have customizable dialogue. Okay, and so they can issue those commands as they see fit. You'll be able to come up with custom intro and outro messages, different endings. Right. A big note here is that we can customize a lot, but we're still stuck in the same genre. We still have the same rules. Okay, and that is something that we're going to want to change. In Homework 7. In my opinion, the best homework in the entire course by a mile is all about that. Okay, that's where Lua comes in, right? Logic becomes customizable in Homework 7. Not this week, though. We got to work ourselves up to that. Anyway, right? It's going to go from this hard-coded adventure to a crazy adventure, right? This is actually footage of, I think, the final integration test case, which has like several million actors all moving around with different dialogue and stuff like that. In order to create this test case, I had to create a test case generator program, all right, to make a big enough test case, because I'm not hand-coding a game like that. Yes?
My concern is that we have this wide open thing.
Yeah.
The camera is still 13 by 7.
Yeah.
Oh, no.
Oh, no, right? Well, actually, I think the camera width is something that's also customizable this week. So you can have a gigantic world, but a very tiny view into it with a tiny camera. Yes?
Did you make a test case for a test case generator?
A test case for the test case generator? I did not. So we'll have to assume it's working okay. This is one of my favorite things about the course. Like, hey, Austin, how do you know the instructor game engine has no bugs in it?
You don't.
Well, here's what we did. Nikhil Ghosh, who was our fantastic IA the first time we ran this course a year ago, he's working at Iron Galaxy now, a truly OP student and game dev. I would make a solution, the staff solution for the homework, and then he would do the homework with his own engine, and where we differed, we would look and figure out who has the bug, and we solved a lot of bugs that way. That was actually a very helpful approach. So anyway, and then a bunch of students went and did the homework, and they were able to make it work. So it's we're pretty confident that there aren't too many bugs. Okay, some tips for this homework: start early, and we're actually serious about it this time. Okay, this homework 4 is formidable. Okay, I think you're really going to enjoy it. It's going to stress your muscles in a lot of different ways. And it really feels like something that's actually kind of useful if you like text adventures. But it is a bigger objective, okay? The performance test cases this week are actually hard, okay? And it is actually okay if you don't get them, all right? We had a lot of students. In fact, Jacob was telling me he didn't get all the performance integration test cases last year, okay? If you don't get all the super hard test cases in a homework, you are okay to go to the next homework, all right? The requirements will change. Sometimes if you've got an incorrect part of your code, that part will actually get ripped out to add in new features, right? And sometimes you don't need complete, total, excellent performance to get most of the test cases on the next homework, okay? So don't get too discouraged. But then again, this is an upper level CS. It's meant to be difficult. And if you want that A+, you're going to have to get in there and really grind for it, okay? But personally, if I were in the course, I'd be shooting for that A low A, A-, get plenty of sleep, have a good social life, and get a nice A or A- in the course and get out of here, okay? That's what I would do personally. That's what I did, okay? I'm surprised they let me into grad school with the GPA I had. Okay, anyway. But you know why they let me into grad school? Because I spent so much of that time not studying. I spent that time not studying on really cool club stuff and on projects and on some research stuff. And so anyway, I guess that's a good substitute. So you've got difficult performance test cases this week, okay? And you've only got a week, so do the best you can. You have a new library you're integrating. Fortunately, this is also a header-only library. So aside from maybe a test case folder that you might get when you download the dependency, just delete those, by the way. You don't need test cases or tests in your repository. If you see C++, like .cpp files in a header-only library, it's like you probably don't want those. You can delete them. But you're going to use RapidJSON. RapidJSON is very nice. It provides a lovely little interface for basically indexing into and grabbing data out of JSON. So if you have a string or a file that looks like this, a bunch of JSON, you can create a document. You can parse the JSON string into that document, and then you can use that document to grab things out of it, like strings or values, floats, integers, stuff like that. And that's how you can, for instance, figure out what X value and Y value to put an actor at. Okay, and we'll go more into a lot of this on Wednesday, actually. I'll have a lot more tips for you on Wednesday. So header-only library, what's one of the downsides of this? You know, the cool thing about a binary, we'll talk more about this when you get to homework 5, which has binaries, SDL stuff. A binary is like pre-compiled. It already has the compiled code there. You just link against it, and you're good to go. A header-only library does not have any binaries. Okay, when you include the headers, that's going into your big batch of source code, and all of it has to be compiled into a binary. So it's going to be slower, okay? No binaries, which makes linking easier, but it makes it slower, okay? So convenient and nice and beginner-friendly, but also slow to compile. We will be doing binaries in the future, okay? So we also only need a small subset of features in RapidJSON. GPT and AI assistants are very good at showing you examples of these JSON parsers. One of my favorite experiences ever with AI assistants, one of the experiences where I sat back in my chair and I'm like, oh my goodness. Oh goodness. Okay, is this actually going to replace us? Is when I had a custom file format. This wasn't even JSON. I had a custom file format. I copy and pasted a portion of that file format into GPT, and I said, hey, GPT, give me a simple C# parser. Write me a C# parser for this custom weird textual file format. And it was perfect. Gave it to me in 10 seconds or 5 seconds, and it immediately was parsing this super weird custom file format. Anyway, this is something you could do, okay? Writing a JSON parser is boring. It's been done a ton. You probably won't learn a ton doing it. I recommend asking your AI assistant for a bit of help so you can get to the fun stuff and interesting stuff a bit faster, okay? Of course, you want to verify it and test it. Make sure you do that so you don't get trolled. But yeah, copy and paste some of the JSON format into GPT. Ask for a quick parser using RapidJSON, okay? And there's a very good chance you'll get something good. Remember your chain of help as well. Try and solve it yourself for 15 minutes, then ask AI, then or in Google, and then ask Piazza and attend office hours, okay? Any questions on this particular homework? It is a natural evolution of homework 3. It is a lot of work, but it is not going to be too crazy or conceptually hard, okay? But there's something that might get you in trouble, okay? And we're going to talk about that right now. Let's talk about memory bugs, okay? How many of you love pointers?
Pointers are good.
Hell yeah.
Sometimes.
Rock and roll, okay? Well, we're going to talk about things like smart pointers in the future, which are aimed at kind of helping you out, okay? However, today what I want to talk about is a particular brand of bug that bites very hard, okay? It is very spooky, and it can be a big bummer, all right? And it tends to crop up around this time in the course, okay? We have a problem on homework 4 and then going beyond, okay? Last week on homework 3, you had a hard-coded array of actors, a vector, okay? You had a vector of hard-coded actors, and that's all you really needed, okay? At any given moment, you just had to kind of read through the actors, and you might have had a data structure to check whether something is already there or not, okay? And, it looked like this. Now, this week, okay, you might have a vector of anything, okay? It might have a handful of actors. It might have no actors. It might have 1 billion. These actors might be the funkiest actors you've ever seen, okay? You just don't know, all right? Things are becoming more flexible, and so you have to be able to deal with that, all right? And so how you store your actors is going to become a question that you have to kind of answer, all right? And the future, right? In the future, you are going to have to decide, should I sort these actors for rendering? In SDL, for instance, you render actors based on their Y position, okay? Because things that are higher up, right, they're in the background, right? You render them, and then you render things that are closer, and things look really good, okay? You might need to do some sorting on the topic of collision detection, okay? So that, for instance, you can do checks on actors that are closer to other actors, okay? That'll speed you up greatly. You might need to break actors out into certain groups, okay? So actors that are in this region, we're going to put them into one group, but then actors that are in this other region far away, we'll put them into another group, and then we'll only do collision detection within the groups. That's a good example, okay? So in this course, where your objects are is a really, really big deal. And you need to think about, where are my objects? For instance, are they in one place, or do you have multiple copies of the same object? A spoiler, you almost never ever want that, okay? Are your objects scattered all over the heap, okay? Or are they in a contiguous buffer, okay? Why does this matter, by the way? We'll talk more about this in a bit. Why does it matter?
Memory traversal?
Yeah. So memory traversal is kind of a big deal when it comes to performance. If you're exploring a bunch of objects that are scattered, all around the heap in random locations, that's going to be a bit slow. But if they're all in one array, and going to one object might put the others into your cache, that's going to be really fast. That's kind of data-oriented programming stuff that is going to be homework 9 material. Yeah?
I guess I have a question about that. So is a vector contiguous?
A vector is contiguous, but vectors have an evil behavior that might happen when they grow in size. Yes, and if you forget about this, you could run into some pain, okay? Yes?
But then, backing up of that, if there's like an array that's, or I guess a data structure that's not contiguous, and your compiler sees that you access it like in a row a lot, index.
Will it optimize it?
Will it still cache it?
The cache prefetchers might be the word that it does.
Yeah, when it gets down to what will the compiler do, the question is, you got to test it. You got to go straight to the profiler, and that's because some compilers, have you noticed that certain compilers will work differently? So code that worked on Windows works a bit differently on Linux, right? And that's how it goes. They are standardized in many ways, but not in all ways. Yes?
Do you recommend delving into the heap with this one, or do you recommend staying on the stack for this particular one?
I recommend sticking on the stack for now. Yeah. Or at least the heap is okay, but I recommend putting things in contiguous locations, okay? Because you're going to be doing a lot of iterating over actors, and it's nice to have them already in the cache. Anyway, we'll keep talking about this, okay? But contiguous versus scattered is a big question, and I think we have future lectures talking about exactly this, so look forward to it. is your data going to be in the host environment or is it going to be in the guest environment? Okay, because a variable you create in Lua is not necessarily going to be accessible and fast to mess with from C++ and vice versa. Okay, you'll worry about that during homework 7. Okay, but here's the takeaway. There are huge ramifications for both ease of use, correctness, and performance when it comes to where is my object. Okay, is it on the heap? Is it on the stack? Are all my objects in a contiguous location or are they scattered everywhere, right? Are they in Lua or can I use them from C++? Okay, we'll talk about this all a bit later. Final question, real quick.
Keep like when you use the new keyword.
Yeah.
Okay.
Yep.
Yeah, but also things like vectors will use
Yep.
the heap themselves.
Yeah, so there's something called placement new, which is basically I want to allocate a big block of memory on the heap that's contiguous, but then I want to put my objects on that contiguous kind of section on the heap, okay? It's kind of how you kind of get both of it. Yes?
Placement new doesn't have to be on the heap, it can be on the side as well.
Sure,
You
yeah.
don't have to worry about lines.
Yeah. Okay, so here's a challenge for you, all right? And this is pretty relevant, I think, to your homework 4. I want to load my actor objects into my program. Okay, so you read through a JSON file, you're using rapid JSON, and you're building these structs, these classes, instances, of actors, okay? And let's say that you store them in an STD vector, okay? Not a bad idea, all right? You call this vector scene actors, all right? Now, you say to yourself, well, I want to store my actors, I want to sort them maybe by name. Okay, or maybe you want to group them or order them in some other way than the order you loaded them in on, okay? But here's the thing, you want to keep your original ordering as well, because just like in homework 3, the original ordering is actually the order at which you need to process things like movement and AI and collisions, okay? So how can you have an ordering of your actors like this, but then have a different ordering, maybe sorting by name? Well, one thing you might decide to do is you might decide to create a second vector of actors, and you copy your actors in, okay, to that second vector, and then you can sort them, right? Fantastic, wonderful, okay? Now, let's say they're sorted, all right? Maybe you say then, I want a map. I want some data structure that allows me to quickly access all the actors in a particular grid position. So what do? You go through all the actors, you figure out where they are, and you create a map. So 1319 points you to the player, because the player is at 1319. Actually, I think I messed this up. It's 1915. Anyway, 17.2, right? Spartan 1, Spartan 2, Spartan 5, okay. 1.5, Spartan 3, Spartan 4. So these don't match up. I'm going to have to go correct these, right? But don't worry about it, okay? So the question for you right now is, with these 3 data structures, all of them useful, how many copies of player exists right now? Yeah, you've got 3 copies of your player actor. One right here in your location to actors map, okay, meant to help you accelerate collision detection. But you also have one right here in your sorted actors by name vector, and you have one in your original scene actors vector. Okay, so what happens, right? Yep, there they are. What happens if you want to update the location of your player? Let's say we're going to move this player to 1815. So you update the player's location, but then you forget to update it here, and you forget to update it here. Where is the player? Is it in the former location, or is it in the new location? You have 3 objects, and it's hard to tell. It is a gigantic mess, because you have 3 different copies of the same actor. You have no source of truth, okay? You have no idea where the player is anymore, and any changes you make to one of these will not reflect on the other 2, okay? What kind of problems could this mess up? This is the kind of problem, memory issue you can run into when, like, suddenly your player seems to be warping around. Like, one piece of code thinks your player is here, but another piece of code thinks the player's over there now, and I didn't move it. This can't be possible. What's going on? When really crazy stuff starts to happen, when chaos just completely reigns, okay, and you're freaking out, you should think probably first to, I've got some sort of memory bug, okay? And this could be the issue. You've accidentally made a copy, and you're manipulating the copy, okay? And that's not what you want. In this case, we have violated a principle called dry. You can look this up on Wikipedia. Originally, it was apparently a military concept, a principle of big organizations that basically says you only ever want to have one authoritative source of truth, okay? In a big organization, here's what can happen. The boss sends out a command, right? And the memo goes out to everyone, but then the boss realizes they made a mistake and they're going to issue an updated command, right? Well, you need to make sure everyone gets that updated command. Otherwise, you might have multiple memos, multiple commands floating around your org, and no one knows which one is authoritative and which one should be used, okay? Huge organizational problem in human orgs, let alone a code base, okay? Anyway, so we violated dry. Dry stands for don't repeat yourself, okay? One single source of truth for every piece of information. You only want one copy to exist. Every piece of knowledge or information must have a single, unambiguous, authoritative representation within a system, okay? And it's a really good idea to try and make sure this is the case. Now, you won't always have this be the case in super heavy-duty performance situations, where, for instance, you might want to cache something or copy something or avoid pointers, which can be a little bit slow, okay? But this is usually what you want, certainly while you're developing an engine. And I'll tell you this, the staff solution never resorts to multiple copies of actors to speed something up. That's a bridge too far. We're not going that route, okay? So in just a moment. If you can stick to don't repeat yourself, keep a single object, right, to represent a single actor, this is going to reduce your copy and paste bugs. This is going to improve your maintainability of your code base, and it prevents memory chaos from breaking out, okay? So in general, I recommend avoid making multiple copies of actors and important objects in this course, okay? Yes, real quick.
Now with this whole thing, you don't make multiple copies of actors, but is it fine to say have one copy of an actor somewhere and then have a bunch of pointers going to the thing? So you can then have, like, let's say, a second vector that has actors sorted in a different way, but it has pointers of the actors stored somewhere else.
I think that's a great idea. Fantastic idea, okay? That's a fantastic solution. Let's look at that, okay? Let's look at what we could do. The idea here for us is going to be we don't want to copy objects, but there's not a whole lot of damage if we copy pointers to those objects, okay? And so here's something you could do. You got to be a little bit careful about this, okay? Because this can blow up if you're not careful. But imagine that you have an array of scene actors, okay? These are all actual objects in this vector, okay? These are your original actors stored in their original order, okay? This is really useful. How do we group and manipulate and sort these actors without messing with that ordering or losing it, and without making any duplicate objects? How do we do it, okay? Well, we're not going to copy the objects. We're going to copy pointers to those objects instead, okay? So instead of creating another STD vector of type actor, we're going to create an STD vector of type actor pointer. And you remember what a pointer is. What is a pointer? Kind of, like under the hood. Like, do you know?
It's the address of the object in memory.
Yeah, it's an address. It's kind of sort of like just an integer, okay? And so what we've got here is not the actor itself. We have something much smaller, okay? And these are just going to be pointers, addresses, that basically point to the location of the original objects, all right? So you can see that in this array down here, we have a sorted order, okay? Player comes first, but then the Spartans come after that. So we can easily look up the ordering and deal with these actors in order, or if we want them in the order that they were loaded, we can go back to the original array and find them there. Yes?
I think there'd be a better type to use than a pointer, actually.
What's that?
I think there's a better type to use compared to a pointer.
I'm sorry,
There's a better type in C++ to use.
a better chap?
A better type.
A better type. I'm sure there is.
But an actor reference?
I can use a reference wrapper.
Yeah. Yep, so reference wrappers, you can use those. I'm sticking to just pointers in this example. But anyway, so this adds a layer of interaction, which does slow things down a tiny bit. But you maintain pointers instead, and this keeps you dry because you still only have one copy of each actor for each actor you loaded. And it is relatively lightweight, okay? These pointers are pretty small. So you can get the player actor, for instance, by doing something like this. This code is a little bit spooky. You got to be careful about it. Actor star, player actor, equals the address of scene actors 5, okay? Convenient for homeworks 3, 4, and 5. Now, there could be a problem here, and this creates a pointer to the player, okay? So now you've got, 2 pointers to the player, but actually 1 player. Okay? Only 1 copy of each actor exists, and that's a good time. But you have to be careful, okay? You have to be real careful. All right? Here's a fun example. I like to think of the original dry data as a database, okay? So here you go, right? An example in code. And again, if you can't see this, you're too far away, you can always scooch up, and you can always watch the stream, which I think I've got going right now, right? Yep, it's going. And you can get it right in front of your face if you watch aarger at twitch.tv.com. But we basically have our database of 10 actors loading in. Okay, actors is our DB. We won't touch that. We won't mess with it. We then have other vectors of actor star, which are kind of our views into that original database. Okay, this even actors array, for instance, will only contain references to the even actors in this actor array, okay? And you can run through and print that out and good stuff. I create a lot of DB classes. It's just how I chose to organize things. You've got scene DB, which kind of tracks the loading of scenes and some operations on them. Actor DB, I think, or actor template DB, image DB, right? Text DB, places where I cache stuff. Anyway, we'll talk more about these later. Question for you. What happens to the original data, this actors vector, if we sort the even actors vector? What happens? Yeah, exactly. Nothing happens. It's awesome. Okay, we can do whatever we want to the even actors vector. It's just a vector of references. Okay, it's not messing with the original data. But what happens if we sort the actors vector? What happens? What happens if we create the even actors, we set up all the references, and then we do a sort on the original vector, the original database? Jose?
All the vectors are all your memory addresses are accurate to the wrong actor.
Yes. Oh my goodness. Complete chaos breaks out. Okay? This will be a complete catastrophe if you do this. All right, pointer invalidation will occur, total chaos, okay? Let me show you what happens. Here's our scene actors array. This is the original data, okay? Imagine a data structure to help us quickly know, at one time, which actors are in a particular grid cell. So here we go, okay? Here is our data structure. It looks crazy, but it works really well, okay? All right, so location to actors, this data structure down here, it's an unordered map of a pair of ints to an actor, a vector of actors actually, allows us to find all actors at cell 17, 2, and 0 one time. Okay, that's very nice. I know these numbers are messed up. I have to go fix them. Now imagine you alter the actors array. You alter this original array, okay? You remove some stuff, you sort it, okay? We've sorted, and then we've removed Spartan 4 and Spartan 5. Okay? How are you feeling now? What's the situation? Like,
we got some dangling pointers to deal with.
Yeah, it's a complete disaster now. Okay, complete disaster, right? It's very scary. and bad things are going to start happening in your code base, and hopefully you see them and realize what you've done. Otherwise, you're going to lose hours, okay? You have dangling pointers. This could very well cause a crash, all right? Because this pointer that used to be pointing to this memory address no longer has something valid in it. We might not know what's even there anymore. These two pointers, if you use them, you might blow up, okay? Segmentation fault or something nasty, okay? But there's also bad business over here, okay? Because player 2 has now warped. We sorted this array, which means that our accelerating collision detection data structure now thinks objects are at different locations than they actually are, okay? Spartan 2, right, has now gone to 1.5, okay? 1.5 now directs you to Spartan 2, okay? 17.2 now takes you to player, okay? Which is just weird, okay? Things have moved without moving. What kind of solutions could we have here? And the most obvious solution is just don't mess with the original data structure, okay? But aside from that, what could we do to maybe fix things up?
You have to regenerate your map.
Bingo. All of those convenient accelerating data structures, like our location to actors map, it's invalid now, but we could regenerate it, right? We could go through, look at all of our actors now, all of them that still exist, and we could start putting them back into our map at the right locations with the right keys. We could do that. It's not going to be super fast, okay? Especially if you have a massive amount of actors, you'll have to go through each one maybe and fix them up. But you could fix it up, and now you could move forward, okay? So sometimes it's possible to fix things up after invalidating pointers. I'll give you a hint, okay? This scenario is going to appear on an upcoming quiz, okay? And you're going to have to tell me exactly what the output of the program is going to be. So you'll have to keep track of some of this stuff. Anyway, recreating your accelerating data structures, the best approach in my experience is just to avoid invalidating stuff altogether if you can, okay? A warning, as you add elements to a vector, it will move. It will jump to a new location on the heap, probably, okay? And that will invalidate anything, any pointer that was pointing to elements on the heap, okay? All right, your vector was right here, and all of your lovely little elements were right in here, okay? You created a bunch of pointers to them, and now it needs to get bigger. Oops, there's no space at that location on the heap. So it jumped over here on the heap to keep getting bigger. It copied all the elements, that's great, but all of your other pointers are still pointing to the old locations, okay, which might not be valid anymore, all right? Bad news. You can use functions with std vector like reserve to prevent those kinds of moves, okay? You're basically telling vector to allocate a certain amount of space that you know you're going to need, and then it doesn't have to resize, and it doesn't have to move, okay? Don't feel too bad about invalidating data structures when you're cleaning up stuff, okay? For instance, if you're going to a new scene in your game, you probably don't care about your data structures anymore. You can invalidate them. You're going to regenerate them anyway. You have to. You're reading a new JSON file, okay? On homework 4, the concept of scenes will become a thing. And you'll have to write some code that loads new scenes, which will have new actors, new locations, okay? You'll have doors. Where you step on a door, that causes a command to run that takes you to a new scene. It's kind of cool, okay? So, and a tip, if you notice just your program is behaving super erratically, you might struggle to debug it, but it'll be helpful if you think to some memory issues like this. Where are my objects? Are they moving around? Could my pointers become invalidated by any of this? The answer might be yes, and then this will help you find the issue. Another thing that's really helpful, version control, okay? If you suddenly notice everything's going crazy, and it used to be kind of fine, and now it's just complete chaos, immediately revert, and then think carefully about what you introduced. Good chance pointer invalidation was caused by something that you didn't think would cause it, okay? Like resizing a vector, it's so easy to forget that that's going to move the vector and ruin everything, okay? Anyway, anyone have any comments or questions? Yeah.
You can look for what happens for each operation, like what iterators get validated by checking the CPV reference iterator validation part.
Yep. So there are references online that will tell you, okay, is this going to mess with stuff? Is this going to move things? And I encourage you to explore that stuff. Ask yourself, if you never asked yourself, where does the standard vector put things? On the stack, on the heap? Is it contiguous? These are the kind of questions to start asking. In a map, in an unordered map, are things on the heap? Are things on the stack? Okay, this might be of interest to you for performance reasons. You can do experiments, you can look things up, and you can profile to kind of figure out what's going on, and I encourage you to do so, okay? All right, so I think what I would like to do, I don't think I want to move on to this question, or this presentation right here. I think this fits better on Wednesday. So I think what we're going to do today is I think we're going to start office hours a bit early, right? I would recommend that you get started on homework 4 as early as you can, and I'd be happy to help you do so. And if you haven't finished up homework 3, you'll have an extra 30 minutes with me right in here. Oh, someone made it. Who is that? Are you in the room? You got to be in the room, right? Someone's in the room. Is that you? No? Okay. All right. Anyway, let's go ahead and get started with office hours. We're about, 25 minutes early. Yeah, we will we'll get you started on these assignments, okay? How many of you don't have to raise your hand, how many of you are still looking to finish homework 3, okay? Still looking to snag some points, okay? Not a big deal at all. Remember, it's only 20% off, and you've got until, let's see, you've got until this auto grader off date right after the exam, okay? So you've got many months. You've got a few months to finish it up. But again, be careful, okay? Because if you end up kind of letting stuff stack and snowball on you, it's going to be really hard to catch back up because new assignments are coming in pretty much every week, okay? So do the best you can. If you need to skip a few test cases, not a big deal. You can move on to the next homework, and it won't be a big loss. You can always come back later at the end of the semester with version control, right, to try and snag some of those final points, okay? Okay, any final questions or comments? Okay, all right. Office hours until 8 o'clock, and for those of you who aren't, yeah, right? So 6 to 7 officially, and then 7 to 8 is 440 office hours, but you can use those too if there are no 440 students, okay? Otherwise, this is definitely one of those lectures I'm going to pack some more advice into to make it longer in the future. But it's good to see you, and I will see you all on Wednesday, okay? Good luck with homework 4. It's another fun one. I really think you'll like it. If you enjoyed homework 3 at all, I think you'll really like homework 4. Homework 5 and homework 6 are the ones that get a bit spicy, okay? So look forward to that. We'll be talking about SDL starting next week. We're going 2D. See you then. All right, everyone online, I'll see you later. Bye-bye.